We are back, and we're learning about randomness in Haskell, eh? Many times while programming, you need to get some random data. That is true. That has happened more than once, yeah. Maybe you're making a game where a die needs to be thrown, or you need to generate some test data to test out your program. There are lots of uses for random data when programming. Well, actually, pseudo-random. Good looking out, yeah. Because we all know that we all know the only true source of randomness is a monkey on a unicycle with a cheese in one hand and its butt in the other. In this section, we'll take a look at how to make Haskell generate seemingly random data. Alright, yeah, just to point out that this is absurd because he's pointing out that the idea of true randomness is kind of absurd. Yeah. Colgatino says, maybe if you did some headbanging that makes learning randomness just easier. I don't think so, dude. No. But last time I did some headbanging, I actually got a little bit of a headache. Yeah. Banging too hard. Right. In most other programming languages, you have functions that give you back some random number. We do, yeah. Each time you call that function, you get back a, hopefully, different random number. How about Haskell? Well, remember, Haskell is a pure functional language. What that means is that it has referential transparency. What that means is that a function, if given the same parameters twice, must produce the same result. That's why it, like we said last time, right? That is why it shows up in the I/O, because I/O is tainted, it's dirty. Now, says, I think I got it. Nice. Good job. I think I got... that happened to me once as a kid. I actually had nightmares about that. I thought I had it. Like a bug that got into my hair. And I was like... I thought I got it out, but then... I was like... you know when you see a lot of ants and your body is itching all over? I was itching all over from that bug, right? Then like an hour or two later, after been going around and just itching, and it was just... Oh, it's so annoying. I can't get rid of this feeling. Then like an hour later, it was like, oh fuck, the bug is still here. And then I got it out. Oh man, I had nightmares about that. I still have sometimes. When my head is scratching, I scratch my head, I'm like, oh shit, is there a bug in here? Awful stuff. It was just a harmless stink bug. I had to be careful not to smash it. Nice. I combed my hair, it's clear. Nice. I haven't combed my hair in years and years and years and years. I don't even have a comb. Use a fork, I guess. Where are we? That's really cool because it allows us to reason differently about programs, and it enables us to defer evaluation until we really need it. If I call a function, I can be sure that it won't do any funny stuff before giving me the results. All that matters are its results. However, this makes it a bit tricky for getting random numbers. If I have a function like this, what you need, you could probably have a random function, but you would have to have a seed, right? And that seed would have to be random. So you would have to get it from outside of Haskell. Like time and stuff like that. Yeah. Note owner says there was a knot as well. I got it. I have long hair right now. It's pretty metal. I have a pretty long hair right now. It's not super long, but it's not very metal yet. It more just looks awful. My hair just looks terrible since I'm not combing it, and it's that in between. But it's getting there. Getting longer. Right. Random number. Number 4. It's not very useful as a random number function because it will always return a 4. That's a way to mess with people. You can just make a function like this. Random number is equal to 4. And then you can have a user call this number. And it's gonna come out as a 4, and then a 4, then a 4, and then a 4, and it's like, what is happening? This is not random. Don't worry, you'll be metal like me one day. Nice, I'm looking forward to it. Yeah, I'm actually looking forward to going to like a metal festival. I haven't been to those properly in a while. Right. Even though I can assure you that the 4 is completely random because I used a die to determine it. Nice. Right, they decided the number 4 with the die, so it is a random number. Because we brought the random number from the outside. Yeah. How do other languages make seemingly random numbers? Well, they take various info from your computer, like the current time, how much and where you moved your mouse, and what kind of noises you made behind your computer, and based on that, give a number that looks really random. The combination of those factors, that randomness, is probably different in any given moment in time, so you get a different random number. So in Haskell we can make a random number, then if we make a function that takes as its parameter that randomness, and based on that returns some number or other data type. Right. Oh, here we go. I present you this giant scary picture of this bug, says NodeRunner. Alright, so if you have a problem with bugs, it might be a good idea to just look away for a second or two. Right, let's look at this bug. That was actually kind of cool. I don't know if it's giant and scary. It's a big picture, but it's not very scary. Except for the eyes being red. Alright, it's gone. I've removed the bug, if you didn't want to see it. Colgatin on tab says, random number is equal to the string that says, roll a dice, you fool. It's a die, is in singular, isn't it? NodeRunner says, yep, the bug is in fact a bug. You've all heard that story, right? Why a bug is called a bug within computer programming? If you haven't, it was an actual bug that screwed up the data in one of the old machines. There was some bug or something in there. That's the myth anyway. I don't know how true that is, but that's what I heard. Colgatinotap says that die and dice are both accepted as singular. I didn't know that. Die is becoming more of an archaic, so I prefer to use dice. Look at that, I didn't know that. I find die to be funny because it's... Well, you can say die and think you were talking about something else. As in passing on. Enter the system.random module. It has all the functions that satisfy our need for randomness. Let's just dive into one of the functions it exports then, namely random. Here is its type, random. Right, so we take a random generator, I guess gen stands for, and a random A. No, this is the type. Yeah, we have a type class, which is a random generator and a random type. Could be anything. And then we have G, which is usually, I don't even know. Then return, oh, that's right, we call our random generator, which then returns our random value and G. That's confusing. Why would we return? Why would we return our random generator? Maybe because we want to use it for whatever reason. If we wanted to use it, it would be a good idea to have access to it, right? Oh, it's a new generator. Oh, it returns a new generator. Look at that. Notrunner says, I'm just imagining being a tech who works on on broken consoles and opening a system and cockroaches just scatter all over the workspace. Oh, it's awful. Oh man, that's awful. I didn't want to image that, no. I agree, Banana Wolf Monkey asks for a quote. God is dead. And no one cares. I mean, a lot of people care, but it was a long time ago God died, yeah. That was a long time ago, that quote. Oh, it's a song quote, I didn't know that. Made me think of Teenagers from Mars by Misfits. They don't care. Ah, they don't care. We don't care? Right, whoa. Some new type classes in this type declaration up here, yeah. The random gen type class is for types that can act as sources of randomness. The random type class is for things that can take on random values. A Boolean value can take on a random value, namely true or false. A number can also take up a plethora of different random values. Can a function take on a random value? I don't think so, yeah, I don't think so too either. Probably not. If we try to translate the type declaration of random to English, we get something like, it takes a random generator, that's our source of randomness, and returns a random value and a new random generator. Why does it also return a new generator as well as a random value? Well, we'll see in a moment. Because if we want to have multiple data, we want to have an array of random data, then we need a new random generator. We don't want to use the same one, so therefore we bring another one. Makes it easy. And song to general, that was what my phone did. Oh, 9 Inch Nails. Oh, nice. We can actually listen to that because 9 Inch Nails released their stuff on it's accessible to just people in general. What's that called? Man, I wish I had Discord open. No, says Notrunner. Was I mistaken? Damn it. Only certain albums are Creative Commons. Alright, so we don't know. Heresy. I'll listen to the song after the stream then. I need to add some of those albums to my music list so we get not only lo-fi, but we can get maybe some 9 Inch Nails and other stuff as well. Alright. To use our random function, we have to get our hands on one of those random generators. The system.random module exports a cool type, namely standard gen. That is an instance of a random gen type class. Can either make a standard gen manually, or we can tell the system to give us one based on a multitude of sort of random stuff. Right. To manually make a random generator, use the make standard generator function that has a type of make standard generator. It takes an int and returns a standard generator. Takes an integer and based on that gives us a random generator. Okay then, let's try using random and make standard generator in tandem to get a hardly random number. Alright, this doesn't work. Random, make standard generator 100, okay. Ambiguous A from the constraint. Random A arising from the use of right, yeah, random what? This is not a complete function. Yeah, I can see this already. Right? We need two values in random. He told us that. We need our generator and we need, wait. We need a value to give us, right? No, right, this confusion, right? We have to decide what type of random value we want, right? Random only takes a generator. Oh, it does only take a generator. So random is not a complete function? Maybe. But is that seems like the song is not there. There is an album. 9 Inch Nails album, but the song is not there? No. The Slip. It is? Wait. Still I'm blind. Wait, what was the name of the song again? The name of the song was Heresy. Heresy is not there. Maybe I'm blind. Oh. You could type 0 plus random and it would work. Right, because it cannot... Oh, but then it's not complete, right? Because you need to imply what type you want. You're not blind, you just need glasses. I have my glasses. I have them on, so that's fine. All right. So the problem is not that the function is not complete. The problem is that we don't know. But we could either by doing 0 plus this, or we could just make a declaration, right? We could make our own function with a declaration of what type to return. Alright, rising from the use of random. Alright, probable fix, add a type signature. Yeah, exactly. Add a type signature that fixes these type variables. Alright. What's this? Ah, right. The random function can return a value of any type that is part of the random type class. So we have to inform Haskell what kind of type we want. Also, let's not forget that it returns a random value and a random generator in a pair. Right, so... Right, you can do this. Entered and then a standard generator. So we get our int. And this is our standard generator. What is with this? Finally, a number that looks kind of random. The first component of the tuple is our number, whereas the second component is a textual representation of our new random generator. What happens if we call random with the same random generator again? Yeah, we get the same stuff. Of course, the same result for the same parameters. So let's try giving it a different random generator as parameter. Right, and then we get something completely different. Node says I saw a bug for a moment and then it disappeared while I was trying to catch it. What a ninja. We'll get in on tab. So, right, so 0 plus random this is not enough. We would need 0 plus the first. Because 0 can be multiple different values. Right, because 0 can be different type classes and we need a specific type, not a type class. I didn't get the same random numbers as GHCI in the book. Yeah, that makes sense. It makes sense that you don't get the same random numbers because of what happens in the background, right? Oh, because it returns a tuple, right? The first. Yeah, exactly. We have to 0 plus the first. The second number is standard. We try to plus 0 with the tuple, that it would throw a fit. Good looking out, yeah. Right, cool, great. A different number. We can use the type annotation to get different types back from that function. Yeah, we get a bool that gives us random. I'm confused about this syntax, why we get two numbers separated by a space. Let us make a function that simulates tossing a coin 3 times. If random didn't return a new generator along with the random value, we'd have to make this function take 3 random generators as parameter and then return coin tosses for each of them, yeah. But that sounds wrong, because one generator can make a random value of type int, which can take on a load of different values. It should be able to make 3 coin tosses, which can take on precisely 8 combinations. So this is where random returning a new generator along with a value really comes in handy. Exactly, you need it to create an array of data. We'll represent a coin with a simple bool. True is tails, false is heads. Right, 3 coins, standard generator, and we return a tuple of 3 bools. Yeah, that makes sense. Right, generate them. Let the first coin be a new generator. Random plus gen, right? Since we have decided bool up here, we know that this is going to be a bool. This is going to be our new generator, right? Then we've got our second coin, which uses the new generator, and then we generate a new generator. Boom, right? And we have a use. Exactly. Just make sure. Something tells me that there is an easier way to do this. Right, if we want 1,000 random values, something tells me that we're gonna run into an easier way to do this than calling it 1,000 times. Node owner says, if is Haskell, send string. I don't see what all the hype is about. right? Yeah. What the hype is about? I mean, hype about Haskell? I don't know. Is there a lot of hype about Haskell? I'm just interested in learning functional programming. And that's what the hype is about, I suppose, if there is hype. Alright, we call random with the generator we got as a parameter to get a coin and a new generator. Then we call, alright, we just do a recursive call, right? Do some kind of recursive call. Or maybe a list comprehension, I don't remember. Then we call it again, only this time with our new generator to the second coin. We do the same for the third coin. Had we called it with the same generator every time, all the coins would have had the same value, and we'd only be able to get false, 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 or true, true, true as a result. Golgitinotab says, nah, with Haskell you need to have 1,000 lines to get 1,000 random numbers. Kappa, right, yeah. Get all that. Notice that we didn't have to do random gen full standard. Yeah, we already specified that exactly with the specified it right here. We want booleans in the type declaration. That's the name. The type declaration of the function. That's why Haskell can infer that we want a boolean value in its case. In this case. So what if we want to flip 4 coins or 5? Well, there's a function called randoms that takes a generator and returns an infinite sequence of values based on that generator. There we go. That's even better than I expected. Yeah, we just call randoms. Right, we just take something from an infinite list. Nice. Utilizing some Haskell stuff, like infinite lists. Perfect. Notrunner says, I still like the idea that computers should ship with radioactive sources for random number generation. Little radiation exposure never hurt nobody. Right? Nice. I mean, there is a problem with that, right? Wasn't it Veritisium who made a video just a few months ago? No, I don't remember where I saw the video, but right? There was this problem where people made computers close to a facility where they did nuclear radioactive stuff. Because the computers fucking broke because of the radioactivity. There was too many flipping bits, randomly flipping bits within the computer. It was even in that video they gave an example where the working hypothesis was that that computer broke and there was a voting tally, right? An actual political election where someone got too many votes. Yeah, cosmic rays, exactly. That was the idea. That's how they figured it out. And it happens with cosmic rays. So shipping the computers with a random number generator like that might not be a good idea. However, what you could do is that you could have build specific computers for random number generation. Just like where, and then you could have an API to that specific computer built for random generators, I suppose. An API, if you really need random stuff. Well, get in on tabs says randomly flipping bits just to get lucky. Easy, exactly, super easy. Just to get some ECC RAM, you'll be fine. Yeah, just buy a house. Yeah, let's just buy a house. Alright, so we take 5 from randoms and then we just take this. And this number We just roll a dice and put the number 11 on here. Also, missed opportunity to put the number 42, wasn't it? True, false. Yeah, we just decide what we want. We want a list of whatever. Very nice. Wait, Colgate General tab says ddf/dev/random of dev/sda is safe if you get lucky. Let's not do that. Yeah, that seems like a dumb idea. Why doesn't randoms return a new generator as well as a list? We could implement the randoms functions very easily like this. Well, because randoms use random, right? Randoms is built on top of random, so you would just, since the list is infinite, you don't need to return a generator. Yeah, it would. There's no need for it. Yeah. Right, randoms, we can create our own. Random generator G, random A, and then we return a list of A, sure. And then randoms with the generator, let value plus new generator equal to random. Oh wow. Oh, I just felt super tired. Lost track of what was going on in the code. I understand conceptually what happened, but the code just looked like French to me for a second. Right, we'll let our value in new gen be yeah, this just looks like French to me, but that's what we did, right? They just implemented. They took the random function and they just created a list. Did it over and over and over again with the generator on every new number. A recursive definition, exactly. We get a random value and a new generator from the current generator and then make a list that has the value as its head and a random number based on the new generator as its tail. Because we have to be able to potentially generate an infinite amount of numbers, we can't give the new random generator back. Yeah, exactly. We could make a function that generates a finite stream of numbers and a new generator like this. Finite randoms. Alright, more French. Okay. We get 0, we return an empty list and a generator. And if we have everything else, let the value, oh man, so much French. Okay, again, a recursive definition. We say that if we want 0 numbers, we just return an empty list. All right, that's how many numbers we want. And the generator that was given to us for any other number of random values, we first get one random number and a new generator. That will be the head. Then we will say that the tail will be n-1 numbers generated with the new generator. Then we return the head and the rest of the list joined, and the final generator that we got from getting the n-1 random numbers. Now runner says, "Are you okay? You need an early nap?" I think well, it's not super early, but I am definitely taking a nap after lunch. But I'm okay. I've just been awake and streaming for way longer than usual, right? Yeah, way longer. What if we want a random value in some sort of range? All the random integers so far were outrageously big or small. What if we want to throw a die? Well, we use random R for range. I really hope that... yeah, exactly. I was hoping there was a random RS. We get the full... all of the randomers. That's kind of like random, only takes as its first parameter a pair of values that set the lower and upper bounds of the final value produced, and the final value produced will be within those bounds. Alright, there's also this, where we can get... that doesn't look like a letter. Nice, looks like a super secret password or something. Super secret. You may be asking yourself, what does this section have to do with I/O anyway? We did ask and answer that at the beginning of the section. We haven't done anything concerning I/O so far. Well, so far we've always made our random number generator manually by making it with some arbitrary integer. Problem is, if we do that in our real programs, they will always return the same random numbers. Yep. Which is no good for us. That's why system.random offers get the standard generator I/O action. Here we go. Which has a type of I/O standard generator. When your program starts, it asks the system for a good random number generator and stores that in the so-called global generator. Yeah, we get it from the outside, right? In-out. The old in-out. Get standard generate fetches you that global random generator when you bind it to something. Oh, we don't even get random numbers. We actually get a random generator. Here's a simple program that generates a random string. System.random main do, and we generate a random string, and it gets random stuff all the time, because here get standard generator. Yeah, we bind that. I wonder if that is this one. Do we just do, I don't remember, do we just do random? No, we do echo. I wonder if it's just that one. You can see we get a random number. If that's the thing that imports. Might be. Be careful though, just performing get standard generator twice will ask the system for the same global generator twice. If you do this, alright, if we call it, we will get this within the same program. We use the same value. No, so it is a single value. Yeah, both of those will be the same. So the first two strings will be the same. Right. We'll get the same string printed twice. Yeah, exactly. One way to get two different strings of length 20 is to set up an infinite stream and then take the first 20 characters and print them out in one line. Oh, nice. And then take the second set of 20 characters and print them out in the second line. Right, so we just create an infinite list. So we take 20 and we return the rest of the list. And then we take 20 off that list. For this, we can use split add, the split add function from data.list, which splits a list at some index and returns a tuple that has... Oh, right. So we could have an infinite... No, wait. Returns a tuple that has the first... Oh, right. That's what we need to do, because we need to drop, right? We need to take this 20 and then we need to drop the 20. I think drop is the one that we go 20 indexes into the list. But we can just split that. Because then we get first number and we get a tail, pretty much. Well, we get the first and we get the second. Yeah, the first part is... it has the first part as the first component, and the second part is... Wait. That's the rest of the list, right? Right, we can import those, we can get our generator, we can let our random characters be... Right, we take a list, exactly, so we get a string between these, and we take our generator, which we got here, first 20 and the rest. Yeah, exactly, that's what I thought, the rest. So we split at 20 random characters, so that's our first, the thing that we wanted first. And then we get the second 20. And we don't care about the rest of the list, because the rest is whatever. Another way to use the new standard generator action, which splits our current random generator into two generators. It updates the global random generator with one of them and encapsulates the other in it as a result. Oh, that's a pretty nice function. So you don't have to mess around, you can just say new standard generator. Not only do we get a new random generator when we bind new standard generator to something, the global one gets updated as well. So if we do get standard generator again and bind it to something, we'll get a generator that is not the same as gen. Oh, right, because this one, since we have a lazy language, this one is dependent on this one, right? It splits up, this one splits up gen. We may, when we call this down here as the third step, that will be the value that we would have gotten if we didn't do this. There we go. Here's a little program that will make the user guess which number it is thinking of. Right, it generates a random number, and then we ask for the number, which will be an IO action. All right, we take a random between 1 and 10, which number am I thinking of? Then we get the line. When not null, number string. Oh, number string. Wait, where did we have number string? There we go. Number string, all right. When that is not null, right, it has to be something. We read it, and if it is... Oh, right. I was thinking that we had to check if it's a number as well, but we don't have to, right? If someone guesses A, they are wrong, because it's not equal to our number. So they can be incorrect in any way they want to be. Since we gave this information, that's pretty good. Else we print sorry it was. Oh, we don't let them guess again. Right, we make a function ask for number, which takes a random number generator and returns an IO action that will prompt the user for a number and tell him if he guessed right. That function, we first generate a random number and a new generator based on the generator that we got as parameter, and call them rand number and new generator. Let's say that the number generated was 7, because it's always fucking 7, isn't it? Well, not always, but 70% of the time. That's so interesting that it's fairly easy. Think of a number between 1 and 10. good guess is 7, because that's what people think of for whatever reason. Oh, hello gang. Willy Kang, nice to see you. How are you doing today? This does not look like C or C++. What kind of language is this? This is Haskell. Yeah. This is Haskell. It's a functional programming language. That's yeah. It's a different way to think about programming to make it look more like logic, I guess. Colgatin on tab says, I think 6, not 7, because it's perfect. Every time. I probably think 4 or 2, because they are both numbers of 42, and I'm a nerd. Right, then we'll tell the user to guess which number we're thinking of. We perform getLine and bind its result to number string. When the user enters 7, number string becomes 7, a string. Next we use when to check if the string the user entered is an empty string. If it is an empty IO action. Wait, do we have to do that? Do we have to do that? Yes, because if they give us an empty string, we would have to have just and maybes, right? We need to return something. Next we use when to check if the string the user entered is an empty string. If it is an empty, return nothing, yeah. Which effectively ends the program. If it isn't, the action consisting of that do block right there gets performed. We use read on the number string to convert it into a number. So number is now the number 7. Oh, here we go. Excuse me. If the user gives us some input here that read can't read, like haha. Can't read a string. Our program will crash with an ugly error message. If you don't want your program to crash on erroneous input, you use reads, which returns an empty list when it fails to read a string. When it succeeds, it returns a singleton list with a tuple that has our desired value as one component, and a string with what it didn't consume as the other. Right, not when it expects a number. Right, of course. Good looking out, call it in the tab. We're expecting a number. Wait, are we? Right, because we're taking a random number. Yeah, of course, we're expecting a number because we could change it around and randomly generate a string with one character between 0 and 9. So we could work around, but or maybe I'm just too tired. Right, we check if the number that we entered is equal to the one generated randomly and give the user the appropriate message. And then we call ask number recursively. Right, only this time with the new generator that we got, exactly. Which gives an IO action that's just like the one we performed, only it depends on a different generator, and we perform it. Main consists of just getting a random generator from the system and calling ask for number. Do function action thing. Alright, here's our program in action. And we're just gonna fail and fail and fail. Another way to do the same program is like this. Yeah, it's a lazy language. Definitely. Functional, lazy language. Right. Oh no, control monads. When? That... We're too early for that. More monads. It's gonna be exciting to actually get to the monads. Right, we get our randomly generated number, and we let our random number be between 1 and 10. Wait, we don't care about... Wait, that confuses me. Right. Which number in the range of 1 to 10 am I thinking of? Number string, we get the line when the line is something rather than nothing. Let the number be read number string, right? We get our int. If rand number is equal to number, then you are correct, or sorry, it was, and then we show the right new standard generator. That's... I was thinking, how can we do it without that one? We use new standard generator, exactly. We have the standard generator and we have the new one. That's why we don't have to care about. That makes sense. Willikang says, interesting. Yeah, it's difficult. Right. It's very similar to the previous version, only instead of making a function that takes a generator and then calls itself recursively, with the new updated generator, yeah, we will do all the work in main. After telling the user whether they were correct in their guess or not, we update the global generator and then call main again. Both approaches are valid, but I like the first one more since it does less stuff in main and also provides us with a function that we can reuse easily. That means that I misunderstood the new standard generator here. It does not work exactly the way I thought it did. You can just rotate these. You can get a standard generator, then you can get a new standard generator, then you can get a standard generator, and then you can get a new standard generator, and they will just work over and over and over again. All right, but I think that was it for today. Yeah, it's lunchtime and then it's time for a nap. Yeah, lunch and some nap, and we're gonna do some byte strings in a couple of days or something. But that is it for me, so thanks for hanging out and have a good one. Yeah. Cheers.